welcome back. So today is day 26 of the Daily Arithmetic Challenge. Okay, so on your screen are the first 6 questions. Pause, have a go. There are a couple more on the next screen. There are 10 in total. Once you've done them all, we'll go through the answers together. Okay guys, time to go through the answers then. The first question is a simple subtraction with decimals. So again, the best piece of advice I can give you is getting those decimal points in line with each other, because then the rest of your place values just fall into place, ironically. Okay, so first of all, I've got 0 take away 1. Can't do that without going into negative numbers, so I have to exchange it from the next value. So 5 becomes a 4, and then that value that I have exchanged comes across into my tenths column. So I have got 10 take away 1, which is 9. I've then got 4 subtract 8. Again, I can't do that without negative numbers because 4 is smaller than 8. So I'm going to go to my next place value, which is my tens column. I have a 1 in there, so I'm going to exchange from that, and that's going to become a 0. There's nothing left in that column. And then I'm going to move that 1 down a place value into my units. So I've now got 14 subtract 8, which is 6. Number 22. We have got 1,692 divided by 9. Again, write out your 9 times tables. I actually did write out my multiples of 9, but have managed to somehow crop that off the bottom. I'm very clever like that. So make sure that you do actually write those out, because it just prevents you from making silly mistakes. So again, as always, 9s into 1 are 0. Cross it out, move it across the place value. 9s into 16, again, only go in 1 time because 2 9s are 18, which is too big, which means I have 7 remaining. I've carried the 7 across. 9s into 79, well, that goes in 8 times, but I still have 7 remaining. That carries across again, and I've got 9s into 72, which goes in 8 exact times. Number 23, much like 21, it's a subtraction of decimals question. Again, get your decimal points in line. I've put a 0 behind my 6 as a placeholder because I knew that I was going to have to do some exchanging in my subtraction, and for that one I got 24.67. Number 24, I love multiplication fraction questions. They are the easiest fractions questions out there. You just multiply your numerators and multiply your denominators together. 1 multiplied by 1 is 1, don't fall into the trap of putting 2 down, and 4 multiplied by 5 is 20. Number 25, you've got a 2-digit number multiplied by a 2-digit number. A nice, easy question again if you got this. I always circle my tens number on the bottom just to remind me that I have to place a 0 down first when I deal with it. And I've multiplied 35 by 6 and then 35 by 30, and then added my 2 answers together to give me 1,260. Number 26. I have got 400,824, subtract 12,490. Again, a straightforward subtraction. The only reason that this question can be slightly difficult is just the sheer amount of times that you have to exchange to make sure that you can do your subtractions properly. So for that one, you should have got 388,334. By 2.5. So for this one, I would have separated out my whole number and my fraction, and I would have partitioned those and done the two things separately. So the first thing that I would do is 13 times 2 and ignore the half. So 2 multiplied by 13, or 13 multiplied by 2 is 26. That's dealt with. I've now got a half multiplied by 13. That question there is basically just saying a half of 13. Okay, you're just having to half the number that you're multiplying it by. Now obviously, we know that 13 does not half into a whole number. It halves into 6.5 or 6.5 as a fraction. And then you would add 26 and 6.5 together, which would give you 32.5. Number 28, we've got 7/10 add 2/5. Only issue with this question here is that the denominators are 2 different numbers, but it's nice and easy to spot what you can turn them both into. You can leave 7/10 as it is, because I can turn 2/5 over 10th 2. And to do that, I multiply 5 by 2 to get to 10, so I have to multiply my numerator by 2 as well, which would give me 4. And then I've got 7/10 add 4/10, which would give me 11/10, which would be accepted as your answer absolutely fine. But some of you may have noticed that that is a top-heavy fraction because my numerator is greater than my denominator. So you may have turned that into a mixed number, and if you did do that, that would be 1 1/10. Number 29, now as you can see, this one would definitely be a 2-mark question in a SATs test, probably found near the end of your arithmetic paper. Write out your multiples of 16. Don't even try and answer this question without doing that, because you're just going to make a silly mistake. Even if you have to add on 16 physically every single time, do that up to at least 5 times 16. So for this one, you can see that I can't get a group of 16 out of 3, so I have crossed that out, put a 0 on top and moved it across to the next place value. 16s into 34 go in 2 times, as you can see down at the bottom, it's 32, which means if I had 34 and I've taken 32 away, I've got 2 left, carried that over to the next place value. I've then got 16s into 22, that will only go in 1 time, because 32 is too big. I will carry the 6 over that I have remaining, and then I've got 16 into 64, which again from the multiples at the bottom you can see go in 4 exact times. Now the next one, we have got 3/4 divided by 3. So for this one, as soon as it's a dividing fraction question, you're going to get your KFC method back out. If you're not sure what that is, there is a video on my channel. You can go and have a look at that to go in more detail. But basically, we've turned the 3 wholes into a fraction, which is 3 over 1, because we've got 3 whole lots of 1 there. And then you would do KFC as normal. Now I've got 2 fractions. Keep the first fraction, which is 3/4. Flip the operation symbol from a divide to a times, and change my last fraction from 3 over 1 to 1 over 3, or 1/3. And then you've got a nice, easy multiplying fractions question, which everybody loves. Just multiply your numerators and then multiply your denominators. 1 times 3 is 3, and 3 times 4 is 12.